the extra nitric dissolved all or possibly most of the copper nanoparticles that were not being dissolved when the solution was too concentrated. And as we can see, there's a lot of contacts down there that are not yet dissolved, which is a good sign. We ran out of nitric on this part. This is the first solution that I poured off. We have only some fine particles. I don't know what they are. So what I'm gonna do is I'm gonna just decant them both, and I'll consolidate whatever's in the bottle in another beaker, or I don't know, possibly another 2 liters, but a 2.5 liter. Let's see. And I'm gonna put little by little these guys now. Right, so I want to control that sediment that is on the bottom. I'm not sure what is in these contacts that is not being dissolved by the nitric acid. So hopefully it's still because of the concentration of the solution. It was too high and it was not dissolving anymore. So diluting the solution and adding, first diluting the solution, letting it consume whatever nitric was, and putting 50 more milliliters of nitric acid to get it going until it's all consumed. So let's see. No more blah blah blah.
The next melt.
So this is, let's say, the 90% top of each one of the beakers. So this is the cleaner part of the solution. This is the 5% before the bottom. So some, what seems to be nanoparticles came out. But it's interesting that even though there are nanoparticles here, there's still a lot of, fine particles, like a very fine sand. I'm avoiding to use discriminatedly the fine, divided, etc., because this is a term in chemistry that means, have a very specific meaning, and people use it colloquially. Anyway, so we have whatever was in the bottom, so I would say about 100 milliliters of dirty solution. Then I went all up close to, I think we have 900, we are already 900 milliliter point. Let's say the top 85% of liquid from both beakers, the larger and the smaller. Everything that was clean, right? So I made sure that I could, pour here only what didn't have any, talking about eyesight. My eyes could be not saying the truth, but anyway, what I perceive it as not having anything. So here, some nanoparticles came together, but just a little bit. But you see that it's more cloudy. It's dark today, rainy, and cold in South Florida. Right? So, and then so the remaining bottom of the two beakers, I would say that we had 150 milliliters of very dirty solution, very loaded solution, and I use it. I think I would say I had 100 milliliters of the impregnated and dirty solution, and I used 50 milliliters of distilled water to clean it down, and I completed to the mark of about 0.9 liters of distilled water. And what I noticed is, even though there are still nanoparticles, attention trying to avoid to use most that I can the nanoparticles, the nomenclature, because it has a specific meaning in chemistry and it's used locally to describe anything that is fine, sand, whatever. Anyway, there is some finely divided, even though I might be wrong because I didn't make any assessment just for the appearance and the buoyance of the particles. But the rest is a very fine sand, so it's a gray sand. And based on what I do, the mistakes I always commit, it can be undissolved silver with something else, or can be silver that got in contact with some chloride or whatever. I don't know. I still don't know. So what I'm gonna do, middle heat, 100 milliliters of nitric. There is a handful of undissolved contacts. Again, interesting. Only the part where the silver lies, right? So, for example, let me see if I can let me grab one like this. This one is perfect, even though they were much smaller. So like this. So you see where the silver is, you see where the copper is, right? So the copper piece dissolved, and we have a handful of the silver part, silver cover, silver layer, silver infused, whatever, that is still there. And so this first part, I'm gonna see what happens with this cloudy solution, if it cleans like the others with the nitric acid. And I'm gonna use out all nitric acid before I put another charge, to make sure I keep on controlling. You know, nitric acid is actually down here. I'm controlling, you know, the solution and the consumption of nitric acid. I always try to, you know, continuously add smaller volumes of nitric acid to always consume everything. I prefer that I have something at the bottom that is not fully dissolved. I try to minimize this, but I prefer this than nitric acid that is gonna certainly give me problems later, right? Use more copper than I need, etc., etc. Blah 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 blah. Right? So let's see. Let's give it a time to play. And there you go. So here it's supposed to be my melting table. It's in the floor. Here's the furnace. It's in the floor because I collect 6 by 4 by 2 metal bricks, right? And I try to find all sorts of different metals for my collection. I like metal, so I make let's say copper nickel bars. They're beautiful. I use the standard 75-25 that is used in coins here in the U.S., but also from other countries. So I had coins from other countries that had that very, very specific proportion of nickel and copper. I made sure I went to the mist, etc., etc. So I made this beautiful bar. That's my favorite. Only I have, for sure, copper bars, brass bar, tone of aluminum bars, pewter bars, lead bars. I have everything. So I have a collection. I like it. I like to melt metals and make those little bricks, and then stamp whatever is in them. It's cool. Kind of off topic, but just to explain why the mess is down here. And also my melting table cracked because of my delicate hands. I was trying to, remove one of the bars from the mold. But anyway, it still stands on the base, and that's what is important. So see you in a few. I forgot to explain. So I get about a gram of placer gold from different sources, friends or coupons, etc. Matter of fact is, I don't know, for every gram, if I pay shipping, like regular shipping is too much. So it's almost for free. And every end of the year, I try to, tally how much I got that year and refine and melt into a bar, whatever. That's interesting. I found out some channels where we can have coupons and sometimes even gift cards from some stores. They allow to buy placer gold from different sources. That's interesting. And I love to do this because it's a way. I don't like to spend gift cards with anything else but silver and gold. And so mostly here, I think this guy is mostly placer gold, if not all placer gold. Something like 28 grams. Oh, we can see. See, here's 1, 2, 3. 28 grams. And this guy, about an ounce, 30 grams, let's say. It's mostly e-waste. By profession, because of my work, I had access to a lot of e-waste, right? And it was enough to melt, smaller, like bits of gold like this, right? In this flask we don't have not even this, so I'm gonna need to have, based on the pins and everything that is here, possibly 5 of these to have 1 of this. But anyway, now I keep on putting. I go anywhere I go, and I find something that I can cut with my hands that is, you know, scrap, trash, whatever. I pick them up and I collect it. So matter of fact, I don't have a lot of access to e-waste as I used to have, right? So these are old memories from my computers. You see, everything it's I cut off from the boards, and this is what I have here. Right here, I have different things. So one interesting thing is there are 3 rocks here. 2 of them, the smaller 2, 100% diamond. The bigger one, I'm not that experienced in calibrating the device to measure. And I calibrate based on the specifications and based on the size, weight, etc. of this guy here. It goes super positive. But I'm not calling it a diamond yet. But even though it's here, I need to find some place where people can help me. These guys, I don't know. Quartz or glass, whatever. I need also to find some jeweler that is patient enough to explain to me what these guys are. And here is where I go accumulating things like iridium, this is our engine sparklers. I cut both parts of the tips, then I clean on nitric, and I have this apparent pure iridium. I can get more, but I don't go out that much anymore. All right, so there are some pearls, some random rocks. I need to have someone to identify what is what here. Some of them might be something a little bit more worthy, I don't know. But these guys here, most of these guys come from, you know, garage sales hunting, where I get mostly, actually I only got silver from those, and some silver plated when I really want to do silver and I don't find anything else, right? So, and a lot of garage sales, that's interesting. You have a lot of jewelry. Sometimes you have lots of jewelry. People look and they think whatever. They're ugly, they don't like it. But if you see, for sure there's all sorts of things, but there's a lot of silver, like 90%, sterling, 80% silver. I have a lot of this. There was once, I wish I had a picture, like a necklace. It was a crazy necklace. It was at least from the 50s, but it was full. It was like a beard, right, of very thin chains of silver, but they were completely, everything there, every metal, including the clamps, or everything was silver. And it was full of rocks like this. They were bigger there somewhere else, but full of rocks like this. I don't know, that lot specifically was full of silver. It was incredible, incredible. And here I have things that I collect as well, like tantalum, the discrete tantalum capacitors, the integrated, if you will, quote unquote, and everything, crystal oscillators. So this is where I keep on storing this stuff. There is another larger with larger flasks.
larger than this, where I put like things that I have in higher volume, like microprocessors, RAMs, or whatever integrated circuit, transistors, etc., and I store them somewhere else. But just to explain why this random intermission is in this silver refining video, right? I was sad because it's April. I didn't manage to get anything this year so far. This is the first, so I'm happy. I used those, gift cards or whatever numbers I had, discount certificates. My wife asked something. Anyway, I couldn't escape. This is the part that I like. I found this vein where these guys, where I can use discount cards, discount numbers, discount codes, gift cards to buy gram by gram, half gram by half gram. There's another 30 grams coming already. It's cool. I really like this. Cheers.
Remember that vial with the green substance. I had it for a while. It was recovering gold from a material that was expected to have platinum group metals. And at the end, I came up with those 3 or so grams of green powder that seems to be some form of platinum precipitate. However, I was studying the refining and recover of platinum, palladium, and rhodium in that order. And the cherry red solution dropped platinum, the brick red platinum precipitate, then the solution became blue, I think. I don't remember the order, but let's just assume it was blue. Then after dropping the palladium, the solution became green, right? The palladium precipitate. So the platinum precipitate was yellow. The palladium precipitate was like a red brick. And from the green solution, the precipitate for rhodium came as green as well. So, I don't know. Let's use my cavity tray to see if I have something and not just copper or nickel, for example. I don't think copper would give me that, deep green precipitate, but nickel would. So let's see if I have anything here. it's inconclusive because what I tried to do here was to dilute the precipitate in diluted nitric acid, right? So I just put 6 milliliters of nitric acid and something like under 50 milliliters of water. Nothing happened, nothing at all. Then I added more nitric acid. Still, the powder remained at the bottom. And what I did next was to just add hydrochloric acid, even with the water there. So this is a dilute aquarella. Might be one of the reasons we still have some undissolved material at the bottom. Might be anything else. And it also might be related to this inconclusive result. Right, it's too dim. Yeah, too dim. For this, I would say that is a very little presence of. You have that greenish rainbow. Palladium of rhodium. But if it was stronger, it would go to the orange platinum too. But anyway, completely inconclusive. So what I'm going to do is I'm going to try to evaporate this a little bit, then add proper aqua regia, let's say more concentrated aqua regia without the distilled water dilution here. Anyway, my hand is going everywhere, so I'm having fun. I had that vial there for long, and decided to do while I'm doing my silver recovery. So this is everything from those smaller and medium-sized home silver connectors. When we come here, this is where I started to dilute these guys, the larger one, industrial or high power, etc., etc., etc. This is where I had, well, hope it's recording right now. So remember that green vial, that vial with the green powder. That powder came during gold recovery, and the assumption from that gold was that platinum group metals were present as well, right? And interestingly, after filtering, I got with a thick, so it was about 3 grams, a little over 3 grams of that, deep green precipitate. And while I was studying, I wanted to learn what you do, how to find out, and what to do if there's rhodium in the pregnant solution. And I found an interesting process end to end It was a little bit more complicated because the person was doing lots of things. But anyway, the interesting part was he had cherry red solution. Then he dropped yellow platinum salt. After the platinum salt was dropped, the solution became blue, and he dropped brick red palladium salt. Then the substance became green, just like as this one. Then he dropped a rhodium precipitate, and the rhodium precipitate was green as well. Right? I didn't revisit that, so I'm just getting out the top of my head what I remember. And I forgot to press record here, so this is my cavity tray. I had 3 drops of the solution here. I use the 2 formulas of stannous chloride test. The thing is, I started to use diluted nitric acid here. About 6 milliliters of nitric acid, and whatever distilled water was needed to go to the 50 milliliter mark. So let's say 45 milliliters of distilled water. Nothing happened. I added more, at least 10 more milliliters of nitric acid. Heat, nothing happened at all. What I did was I just added, in the diluted nitric, I added hydrochloric acid. With heat, it started to dissolve immediately. So I add a little bit more hydrochloric acid and keep on low heat. But it's a very diluted aqua regia solution, right? And this is a very inconclusive result. If it was gold, it would be a false positive for sure. Just like when you add a lot of SMD, and you get something close to this. Or copper can give this false positive as well, right? Again, copper could give this false positive as well. So trying to find out if I had something precious or not nickel or copper. I don't believe copper because of the green precipitate. I don't think it will be copper. So where's my copper to chlorate jar? I don't know. That I will compare. And could be nickel. But all I'm gonna do is I'm gonna try to concentrate the solution to have the water to, evaporate away. Then I'm gonna have the concentrated aqua regia solution, and I'm gonna come back with the stannous test. I think I'm gonna replenish or to make a new stannous chloride test vial here to help me with get more precision in the results as well. So I think it's worth my while. Okay, and everything while I'm doing the video where I'm recovering silver. Right? So these guys are from the smaller circuit breaker disjuntor connectors, relay connectors, etc. These are the home use, internal home use silver layered connectors. I added the larger ones here, the medium-sized ones, the ones that I called as being for power towers and air conditioners, because I assume that was excessive nitric acid still remaining here. I don't know. And from those, I had this in the strainer. So this is pure nitric acid, nothing else. Pure nitric acid, concentrated nitric acid. I add everything that was on the bottom that I thought, I mentioned before in the video, I thought these were the silver part of the silver contacts that do not dissolve. It doesn't seem so. I don't know what it is yet, but what I'm gonna do is to go to Aqua Regia later and also see if there's anything that is magnetic still, right? These are the two things I'm going to do. And here I started to dissolve these guys here, the industrial or high power silver connectors. And I left this overnight to settle, to see what type of fine particles I would have at the bottom. That's interesting. This is something I don't know, because I incinerated everything. So what could be this powder, these particles at the bottom? So I don't know. Usually when I do, let's say, sterling silver, I have this fine powder at the bottom, but it's usually because there's always silver chloride when I do this, right? Always. And I accumulate those in silver paper, filter papers. When I have a bunch accumulated, I extract silver from those guys. But I do everything. So I incinerate them, then I go to nitric, whatever silver is left, then I go to Aqua Regia to see if there's anything else, right? And I'm curious, because what could we have in this power break disjunctors, relay connectors that doesn't dissolve in nitric, right? Interesting. Even the colors are interesting. But anyway, I'm gonna come back with heat here. I'm gonna see if all the nitric is consumed in this old fella, and I'm gonna continue to add these bigger guys, to dissolve all of them. For now, they're separated from the small and medium. So I think I'm gonna keep this way so that I can compare. From 1 pound, about 45%, or the thing is the size. So in terms of weight, it was about 50, right? In volume, we have a lot more. We had a lot more of the other, but considering the weight was 48, 52%. So that's going to be fun. And I'm going to compare with similar weight of sterling silver as well. So I'm going to have 3 batches. 1 batch of these industrial connectors, 1 batch of the home use connectors, and 1 batch of sterling silver. So about 200, something like 235 grams in each one. About, right? Let's see what's the yield. It's not going to be precise, of course, but anyway, hunky-dory. Also, I'm gonna, clean this baby here to start filtering, right? I already have lots of stuff to filter, and if I want to keep the 3 batches independent one from the other to kind of measure yield for each type of source material, it's better to start using the 5 liter flask. Blue leftovers from the previous. Where's my silver? Yeah, definitely from the previous silver recovery, right? And this guy goes to heat as well. I put the wrong guy here. I put the nitric with non-dissolved nitrate stuff. This guy goes to medium heat. Now I can say hunky-dory.